Welcome to Live Labs. Today we're going to simplify microservices with the Oracle database. Yes, there are converged features in the Oracle database. My name is Marion Smith and I'm part of the Oracle Database Product Management team. I'm going to take you through this workshop today. So what are we waiting for? Let's get started. First, a little bit about what you and I are going to do today. There are all these cool capabilities inside and outside the Oracle Converged database that support a scalable data and event-driven microservices architecture. We're going to explore them today. We're going to create an app with the Helidon microservices and a JavaScript front end using REST and messaging for communication. The application will be deployed on Oracle Cloud Infrastructure Kubernetes Cluster, OKE, and access pluggable Oracle Autonomous Transaction Processing databases. On my screen, you can see the instructions on the left and my web browser on the right logged into the Cloud Console via oracle.cloud.com. I am using my free trial account for this live lab. First, I'm going to set up my home region. Next, it's important that I make sure I have enough credits to execute this workshop. So let's go to Governance and Administration, Governance, Limits. Let me make sure I have enough compute. I will also go to my Tenancy Explorer to make sure. If not, I may need to delete one of my compute instances I was using for another test. Okay, now that that's done, it's time to start Oracle Cloud Shell. The Cloud Shell machine is a small virtual machine running a bash shell, which is your access through the OCI console. I click the icon to start. Once it starts, I'm going to make a grab dish folder and go to it. Next, I need to get a copy of the workshop scripts and code, so I'll run git clone to pull that down. I almost forgot. I need to update my bash RC file. Let me do that now. So the setup is in a script that I pulled down. I'll execute that now. The script asks me for my user OCID. This is my unique Oracle Cloud identifier, so let me grab that. Copy it and paste it into Cloud Shell. The setup is asking me for an admin password for the databases. I'll enter that now. I'm going to use that same password for the UI password so I can remember it. So now while the script is running, you see you will get an object storage bucket, 2 ATP databases, an OKE cluster, which is our Kubernetes OCI service, and container registry. So to do that is easy. I'll just duplicate my tab and run the ps unix command and examine the grab dish log. Once it's done, we are ready to move on, so let's go. In this lab, we're going to deploy and access the microservices. So first, I'm going to run the deploy script out of the grab dish home directory. I'll then use the kube control command to make sure the services are running. Kube control is the Kubernetes command line tool. Kube control allows you to run commands against Kubernetes clusters. Now I'm going to check to make sure my load balancer service is running, and I'll note the external IP address. Okay, ladies and gents, let's access the front end page now. We'll take that IP address that we noted down and open up a browser. My certificate is self-signed, so I'll just need to allow access. I'll log in using the grab dish user and the UI password I chose during setup. Good thing I wrote it down. Let me try to place an order. I'll go to the menu and click transactional. Type sushi in the food field. The count is 0. I want to order it, so I'll click the place order button. Ah, the order failed. Why? Well, we checked and there was no inventory. Okay, let's add sushi to the inventory. Let me click place order, and now I want to see my order. Success. So let's talk about what happened. While this looks pretty basic, it is far from that. In the back end, there wasn't a two-phase commit in the resulting logs. We used a Saga pattern here, which let the service perform its transaction and publish an event. The other services listed and then performed the next transaction. So what services? There's a front-end service which is in the mobile ordering app. It talks to the order service. The order service inserts into the order database and sends a message, creating a message in the advanced queue or AQ. So implementing AQ in the database eliminates complexity and delivers the message exactly once. Let's explore spatial. Back on our app, let's click on spatial. I'll click on Show Me the Fusion menu to make my choices. I want to add some stuff to my order, and now I'll click Ready to Order. I want it delivered to the Oracle office, and it's on its way. What we just did shows how geocoding can be used to figure out addresses and the best routes. There's an Oracle Map Cloud service being used for geocoding and route finding. Okay, now we'll explore the metrics with you. Clicking on Show Metrics, there's this long string of metrics, including my place order time and count. Now let's see how OKE probes pick up the health of our Helidon microservice. Back on the metrics page, I click Show Health. Back in my Cloud Shell, the YAML file shows the liveness probe. So I'm curious how OKE is going to manage these pods. Let me click on the last container start time and set liveness to false. This will cause OKE to restart the pod or microservice. Back in Oracle Cloud Shell, let's examine the Kubernetes deployment YAML file to see how to connect to an ATP instance. There's the database connection information, the wallet info, network info. I'll use kube control to describe the wallet info. Okay, let's look at this micro profile properties file. It has the definition of data sources that will be injected. If I examine the Java, the inject portion has the data source under named as @order PDB. In this lab, I'll undeploy the Java Helidon MP microservice and deploy a different one and test the functionality, so let's get started. I've already opened up a web browser and logged into Oracle Cloud and started the Cloud shell. I'll run the undeploy.sh shell script to delete the inventory Helidon service. So in this workshop, there are 6 different implementations of the microservice. You can pick any that you want. I'm going to pick Python. Let's check to see if everything worked and run the pods command, which is just a shortcut of the kube control command. We'll go back to the Grab Dish Explorer and use different order IDs this time to look at inventory and do some exploration. To redeploy, I'll run the undeploy command and issue the commands from the workbook. Want to see how microservices applications can scale at both the app and database tiers? Let me show you. So first, I need to install a load balancer for the order service. This will handle some of the scaling. I'll set an environment variable LB to my IP address. Now I'll install a load testing tool called K6. So let me do a load test with this K6 tool by running test.sh. It will take a bit to run. I'm taking note of the response time. So that's the response time with one replica, but what if it's busy time and we need to add more? I'll add 2 additional microservices and you can see them running the pods. Once they are fully up, which I'm checking here using the pods command, I'll execute the load test on this scaled environment. Let's look closely at the average response time for the requests. The throughput did increase, that's good. That's what we want, but the response time is normal and we didn't experience latency, but able to get more orders through our servers. Let's do this again for 3 services. As we keep adding these additional app services, our customers don't experience any delay and the throughput increases. Fantastic. Let's see how easy it is to scale the database tier. We navigate to ATP by clicking on the Oracle database, ATP in the menu. I need to select the compartment where my ATP instance is sitting so that I can access it. There it is. Let me click on it. Click on Scale Up/Down. Choose to OCPU and submit. It will take you a minute to scale up. Once it's available, I can go back and run another load test. Great results and so easy to do. So you know what they say, what goes up can go down. What if you don't actually need that much? We can easily go back to ATP and scale it down. We can also reduce the containers back down to 1. Wondering how to trace microservice activity? Me too. In this lab, we will trace microservice activity using Yager. Back to my Oracle Cloud Shell. I'll run the install script. This will install Yager, an open source software for tracing transactions between distributed services. Prometheus monitors Grafana visualizes data stored in Prometheus. Loki is an HA system inspired by Prometheus. Promtail attaches labels to log streams. Once it's installed, we create some Prometheus monitors to scrape the microservices on the front end, inventory the app, and database tiers. Let me now install Grafana. Remember, it visualizes data stored in Prometheus. I need the Grafana IP address. Here it is. I'll take this and open up a new tab. You may get certificate warnings. It's self-signed. Log in using the user and password I was provided in the lab sheet. I'll expand configuration to access the data sources and test it to make sure it works. Okay, let's add a Yager data source, populated with a URL provided in the workbook. Add another data source for Loki with the provided URL. This one needs derived fields, so let me add those. Click Save. Let me import the GrabDish dashboard using the JSON provided in my workbook. Upload and then import it. Now I'm in the GrabDish dashboard. There are metrics about the CPU, load, place order count, sessions, and inventory. To see this in action, I'll place an order. So I want to drill down in the average time it takes to place an order, which is super important. I'll dive in and split the Explore screen, select the Loki option on the right. I'm looking for the order PDB in the microservice. I click Show Logs, voila, it shows the corresponding logs. Cool. I want to drill down further since Promtail attached labels. I can see the Yager and drill down in detail. In this next one, we'll test failure scenarios and explore how much better the ADB-backed AQ service performs against Mongo and Postgres. First, let's install MongoDB, Postgres, and Kafka. We'll undeploy the services we had and deploy the implementations backed by Mongo, Postgres, and Kafka. Let's check all the pods and services to see if they are running. Okay, back to the GrabDish app. We'll add inventory until the inventory count gets to 10, so I'll keep clicking. Let's crash this service before the order message is sent out. Now I click Place Order for Order 66. It has hung due to failure. Let me refresh my browser. I am getting a connection refused message because the order service was crashed and restarted. When I click the show order button, I see it, but it's in this pending state. If I click the get inventory, I see inventory is 10. Now, if I crash the inventory service after the order message is received and place order number 67, that new order is in pending status. Meanwhile, the inventory service restarts and receives the duplicate message for the order. I'll click show order a few times until I get a successful order status. It's successful, but the message is duplicated. If I click the Get Inventory button, inventory has been reduced to the correct value of 9. Let me click Crash Inventory again, doing this before the inventory status message has been sent. I'll place another order and it's pending. So the order is successful, but there's a duplicate message. This is incorrect. When I click on Get Inventory, I have 7 sushi in my inventory left. Yikes, this is incorrect, and is due to the nature of the architecture I have set up. This will not work. If you've ever ordered something, been excited, paid, and got a shipping date only to get an email later that the order had to be canceled due to no inventory, this should hit home. Let's undeploy the Mongo, Postgres, Kafka based order and redo this with Oracle plus advanced queuing. We will add inventory until the inventory count gets to 10, so I'll keep clicking. Let's crash this service before the order message is sent out. Now I click Place Order for Order 66. It is hung due to failure. Let me refresh my browser. I am getting a connection refused message because the order service was crashed and restarted. When I click the show order button, I see the order was automatically rolled back. Interesting. In the Mongo Postgres backed, it still showed in pending stage, which was clearly wrong. If I click the get inventory, I see inventory is 10. Now if I crash the inventory service after the order message is received and place order number 67, that new order is in pending status. Meanwhile, the inventory service restarts and receives just one message for the order due to implicit rollback. In the previous example, there were duplicate messages. So this is really looking good. I'll click show order a few times until I get a successful order status. I'll place order number 68, click show order, and voila. The inventory was dropped to a correct value of 8. With the Mongo back service, it dropped to an incorrect 7. So you can see that with Oracle plus advanced queuing, the data can handle failures and there's no guessing game to be played. Try this for yourself, don't take my word for it. To learn more, go to the bit.ly on your screen to access the workshop and other workshops to help you develop solutions on Oracle's cloud. Thanks for watching and see you in another timeline or maybe just another live lab.